Hello, my name is Josh Schilling. I am a student here at GT, and this is my charged tapes experiment for Physics 2212 at Georgia Tech. The structure of this presentation will be a conceptual introduction, followed by an experimental procedure overview, then a summary of the experimental results and calculations, and finally the assumptions taken during this experiment. Assumptions made. Conceptually, the experiment was to measure the amount of charge that were on each piece of tape that was given a charge, and this was done by measuring the distance between two pieces of tape and then finding the gravitational force which would be equal to the electric force between them. Okay, the first step was to give each piece of tape their charge, which was done by removing it from a surface, leaving the removed piece of tape with an excess of electrons, which gave it a net negative charge. This was tested by bringing a hand close to the tape and seeing that they attracted, which means that there is a net charge on the piece of tape. The next step was to position that charged piece of tape between some heavy items to keep it in a semi-taut position. In the diagram, it is tape B. Then another piece of charged tape A is brought from underneath tape B and brought close enough that a visible force is exerted on tape B, which causes it to move upward. Tape A is then held in a constant position while the distance between tapes A and B is measured. This measurement of distance associated with, as well as the weight of the tape and the length of the piece of tape, is then used to calculate the gravitational force that is acting on the upper piece of tape, which is 0.001962 newtons. The distance between the tapes was an average of the three trials which were conducted, which would be 0.04 meters, 0.03 meters, and 0.04 meters, respectively. The gravitational force that was calculated is then set equal to the electric force, which is exerted on tape B by tape A. That electric force is equal to the formula on the left side of the screen. From setting the electric force equal to the gravitational force, you can then plug in constants and experimental values to determine Q, the charge on each piece of tape, which is the same, and the excess charge was 1.709 times 10 to the negative 8th coulombs, meaning that the amount of electrons on the excess amount of electrons on each piece of tape was approximately 1.068 times 10 to the 10th, and an according electric force on the upper tape equal to the gravitational force on the upper tape, 0.001962 newtons. This was then modeled using Python and GlowScript. The actual code that I wrote is on the right, and on the left is the diagram that was created by this code. On the left, you can see that the yellow and green dots are the actual pieces of tape, and then the red arrow acting on the upper dot is the electric force pushing it upwards, pushing that piece of tape upwards, and then the blue arrow is the gravitational force pulling it downwards. They would be equal so that there is no net force. In the process of this experiment, air resistance was ignored because there is no motion. The piece of long tape were treated as a single charge so that it could be more easily modeled, and it was assumed that the amount of charge across the tape was evenly distributed so that it was more calculable from the experimental results. If electrons and protons had switched charges, there would be absolutely no effect since the negative and positive was assigned by humans to the intrinsic forces of the electric charges. So the forces would not change, merely our way of viewing them. Finally, handling the tapes was as little as possible was important so that they would maintain their charge, so that they had the approximately the same amount of charge, and so that they did not lose charge. Thank you.